Good morning, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm host for today's session. And we appreciate your time and attention for the next hour or so on a topic that is of particular interest to a large number of us. Before we start the presentation, before I introduce the guest speaker, would like to run a couple poll questions just to kind of see where the audience stands with the topic, and we invite your participation and contribution, and it will help the speaker kind of aim or direct his material as well. So the first question is, are you familiar with the new Arc Flash Ppe category in Z462, the current version, Category 5? So if you would please, no obligation or liability, kind of help us with some feedback as far as your standing on the topic. And there's no right or wrong answer, just strictly trying to see where people currently exist in the exposure to this. There's some interesting points of separation between Z462 and Nfpa 70E, and I, for one, am very interested in the material that we'll be seeing here in the next few minutes. Okay, looks like we have a quorum on this question. Here's how people have weighed in and responded. So like most people are in my category, so we're in the right place to get the new information. And then the second question is, according to the current version of Z462, what's the minimum level of hazardous voltage? Again, this is an area where there's a delineation or a separation between Z462 and Nfpa 70E. And it's good to know where the chips fall based on the customer base you're trying to serve. So it looks like we have close to a quorum here. Thank you for your input. Here's how folks have weighed in. Now, there is a right answer here, and we'll wait to see what Simon has to tell us because I'm not the authority on it. But thank you for participating. And then the third question, where do you stand as far as your adoption of the 2018 Ieee 1584 standard? So let's get some feedback here. And this is another area where there's not necessarily a right or wrong answer, but it's good to know people's standing and their opinion as to how things should proceed. So it looks like we have a quorum here. Here's how folks have weighed in on this question. Looks like we're pretty evenly split on this one. Good. Well, again, thank you for your participation. I'd like at this time to introduce our guest speaker. Simon Guillard-Leroux is a professional engineer with the CIMA Plus organization. And give me a second and we'll hand him the podium. Simon, you have the baton.
Thanks, Jim. So I'll share my screen, just 1 second.
Perfect.
All right, so hi everyone, welcome to this webinar. I'd like to start by thanking EasyPower for the invitation to hold this webinar today. So the subject today, as Jim mentioned, is the 2021 update of the Canadian CSA Z462 electrical safety standard. So there's been an update. The last version was a 2018 version, so a lot of changes in this new version today. So I'll start by introducing myself. So my name is Simon Guillard-Leroux. I'm a professional electrical engineer in the province of Quebec. I work at the CIMA Plus engineering firm in Sherbrooke, Quebec. So I'm mostly specialized in power system studies and so arc flash, short circuit protection, transient studies, etc. And also commissioning for substations and factories. So The plan for today is I'm going to start by stating the objectives for this webinar. Then, as a small introduction to the subject, I will go through the electrical safety standards that apply in Canada. So there's the OHSA, there's the Canadian Electrical Code, there's Bill C-45. So I'll go over these and tell you what's the place of the CSA Z462 in Canada. Where is it called? Is it mandatory by law? Things like that. Then a big change in the 2021 CSA Z462 is that the Ieee 1584/2018 is now mandatory. So there was a bit of a gray zone for the last 3 years. Technically, you could still use the 2002 version for your RX flash equations, but now it's mandatory. Then I'll go through the other changes. There's a lot of changes, as you've seen in the poll questions. There's a new Ppe Category 5. There's been a change in the minimum hazardous thresholds for voltage. So I'll go through these, and then at the end we'll have a question period. So if you have any questions, don't hesitate to ask them at the end of the webinar. So the objectives for today, I'd like to start by stating the past webinars I've did. So I did 2 other webinars previously for EasyPower. So these go in subjects that are linked to the subject today. So today I'm going to be talking about the 2021 update of the standard. But if you want to hear more about the standard itself, and also another standard, which is the Cannual CS801, which is basically the equivalent of Z462, but for utilities. You can check the first webinar that I put the link there. And I presented another webinar on the Ieee 1584/2018 update. So in this in that webinar, I went through in details the new equations, the new methods, the new parameters. I'll go through the main changes in the 2018 version, but if you want more details on the equations and all that, I invite you to check this other webinar. So for today's webinar, I hope you will be able to get a little glimpse of how and when to use the CSA Z462 standard, and also understand the changes in the new 2021 version of the standard. So, as a small introduction, the electrical safety standards that apply in Canada. So we'll start with the Occupational Health and Safety Act, which is a law that applies in Canada. We have the Canadian Electrical Code, which contains Rule 2306 and also Appendix B. So this rule refers to the CSA Z462. So sometimes I get asked by clients, is the CSA Z462 mandatory by law? Well, not directly, but it's called upon in the Electrical Code and in Rule 2306, and also in all the provinces' individual codes. So other applicable standards, we have the Canadian Bill C-45 that explains the liabilities, puts the law, explains the liabilities of the employees, the employers, who's responsible when there's an arc flash event, when there's injuries or death in the workplace. And the CSA Z462, it's the electrical safety standard that applies in Canada. It's based upon the Nfpa 70E, which is the National Fire Protection Association, the US agency. So it's very based upon Nfpa 70E. Both standards are very similar. There's also the Ieee 1584/2018. So this one is, it states the methods of how you get your arc flash energy, how you get your arc flash boundary, what are the formulas you need to use during arc flash studies. So these formulas are all built in software such as EasyPower. And there's also Cannual CS801, when you're a utility, either public or private, it is this standard that applies instead of CSA Z462. A bit of history on the standard and on arc flash and electrical safety. So 1979 was the first version of the Nfpa 70E in the US. In 1980, there was some research work by Mr. Lee, who came up with the first equations to evaluate the arc flash incident energy when there was an arc flash event. Then some work in 1995 came up with the terms for some arcs and limits of approach. And then the first version of CSA Z462 is quite recent, so it's only 13 years old. First version in 2008, and then every 4 or 3 years there's been a revision. So 2012, 2015, 2018, and now 2021. So keep in mind that every revision usually brings a lot of changes. Just to give you an idea, in 2015, there was a big change with regards to could you use the incident energy method, so the detailed modeling and the use of a software such as EasyPower. Could you use the incident energy levels to give Ppe categories on your labels? Well, this became prohibited in 2015, so this was a big change in the industry for us. So I'll go through the changes in the new revision. Just to give you an example of the liabilities that are prescribed in Bill C-45. So this is an example of a court bulletin for an arc flash event that happened in a factory in Ontario. So there was an arc flash event, and a worker was injured because he had no proper PPE, so he had no rubber gloves or a face shield, and the company was fined for this. Just to give you some more details, so based on OHSA, so Occupational Health and Safety Act, there's responsibility for the employer and the workers. So for the employers, it needs to ensure, as far as reasonably practicable, to take every precaution to ensure the workplace is safe. So, for example, to follow the CSA Z462, apply safe work methods for its employees. It has also the responsibility to train the employees. So there's been some changes in the 2021 CSA Z462 about training requirements. For example, it covers now like remote online trainings for COVID purposes. And also, it adds some new requirements for training, so I'll tell you about that. And the employer needs to supply PPE, so personal protective equipment, and ensure the workers know how to use the equipment safely and properly. And then on the workers' side, every worker shall work in compliance with the OHS acts and regulations, use the PPE as directed by the employer, and also take reasonable care to protect the health and safety of the worker and workers around him or her. So basically, everyone is responsible for the safety of everyone else. So you are responsible for your own safety, for the safety of your colleagues. The company itself is responsible for the safety of its employees. So there's a lot of liabilities with regards to workplace injuries or deaths in Canada. So keep that in mind when it comes to applying the CSA Z462. Well, this gives weight to the application of the standard. So where is CSA Z462 called in the Canadian Electrical Code? So it's called in Rule 2306. So basically, the rule says that for shock and arc flash protection, electrical equipment such as switchboards, panel boards, control panels, enclosures, and MCCs that are installed other than a dwelling unit and are required and are likely to require live work. So live work can be examination, adjustment, servicing, or maintenance. It shall be field marked to warn persons of potential shock and arc flash hazard. And the subrule 2 says that it shall be located so that it is clearly visible to persons before live work. And then if you go to Appendix B to get details about this rule, you see that the first statement here says that CSA Z462 can be used to determine the severity of arc flash hazard and shock hazard, and to determine safe work practices and select PPE. So this is where the CSA Z462 is called upon. So now let's get in the new standard. That's the new version of the IEEE 1584. That's now it is now applicable officially. The thing that happened for the 2018 CSA Z462 is that it came out 1 or 2 months before the IEEE 1584 2018. So there was a period of 3 years where you could still use the 2002 or the 2018, but now it's officially moved on to the 2018 standard. So I will go through the major changes here. So basically, it's referred to in Annex D of the CSA Z462. So this new RFID standard is the first update since 2002. There were some amendments in 2004 and 2011. So these equations for arc flash that now apply are based on empirical data. So basically, the 2002 version was based on around 300 tests performed by the IEEE committee. But now they increased the number of tests, and the equations are now based on around 2,000 tests. A new configuration, a new parameter in the arc flash equations now is the electrode configuration. So which was not presented in the 2002 version. So you now need to specify for each bus, you need to specify the electrode configuration. So you need to specify, is it VCB, VCBB, HCB, VOA, HOA. So if you want to hear more details about that, I encourage you to view the webinar I gave on this specific subject. So a new addition is that the enclosure size of the equipment is now used in the calculations, which was not a thing in the 2002 version. So you now need to specify for each bus the height, the width, and the depth of the enclosure if it is an equipment inside an enclosure. So this adds a bit more depth to the requirements of the arc flash surveys. Also, the limits were a bit extended. So the voltage limits are the same between the two versions. Basically, it's still 208 to 15 kV, three-phase systems. They extended the range for short-circuit currents, though, so it applies to a larger range of short-circuit currents now, and it also applies to a larger range of distance between phases. When these model ranges are not applicable, normally software would change to the Lie equation or any other method. So now, knowing that the ranges are larger, well, that the model applies to more situations. Another big change is that the system grounding. So are you delta? Are you floating Y? Are you solidly grounded? It was a parameter in 2002 arc flash equations, but it's not anymore in the 2018 equations. So with the tests that they've performed coming up with their equations, they ended up concluding that the system grounding type was not an important parameter to calculate the incident energy. Another important part is that the 2-second limit still applies. So the 2-second limit, basically, when you calculate an arc flash, you cap the maximum arc duration at 2 seconds in most situations when there's enough clearance around the equipment and there's no physical limitations that prevent the worker from leaving the source of the arc flash. So basically, the text has been slightly changed, but the spirit is still that in most situations, the maximum arc duration would be reasonable at 2 seconds. So this still applies. A big change is that the cutoff limit at the minimum limit at which you need to consider arc flash risk and consider equipment in your arc flash study has been changed. So beforehand, the cutoff was that if you were below 240 volts, the distribution needed to have a 125 kVA or larger transformer. But now this has been changed to below 240 volts and with a short circuit current over 2000 amps. So basically, you need to know actually the available fault current to determine at which point you need to put your cutoff in your distribution. So what we can do is we can estimate what is the equivalent of in terms of transformer size to obtain a fault current of 2000 amps, let's say at a 208 volt secondary transformer. So we can calculate the power of this transformer, which is square root of 3 times the secondary voltage times the fault current times the impedance. So let's say we take a conservative impedance of 4%. We get that it would be equivalent to a 29 kVA transformer. So before it was 125, now you can estimate it at around 29 kVA. So you need to go much further down in your distribution than before. There was also in the 2002 version a paragraph that stated that you only needed to model large motors over 50 HP, so 50 HP and larger. So this exact text with the 50 HP has been removed from the standard, but it still refers to large motors. And then in other references, you can find the 50 HP limit. So based on other standards, we can say that the 50 HP limit still applies. Now the recommended method for over 15 kV. So remember the limits of application were 208 to 15 kV 3-phase. So what did the standard say when you were over 15 kV? It said use the Lee method, but now it doesn't say explicitly the Lee method. It says you can use other methods. So basically, this opens the door to other methods, such as the one that's built in EasyPower, for example. So the Lee method was sometimes a problem in our flash studies because it was very, very conservative for high, medium to high voltages. So this, just to give you an idea, is the equation of the Lee method. So it was as simple as that. Just a constant term multiplied by voltage, voltage fault current, arc time divided by working distance squared. So the new methods for higher voltages are a bit more complex, of course. So single phase systems, they were not covered by the 2002 versions. 2018 version still does not cover them, but at least it gives a method that you can use for single phase systems. It says you can use the same equations in the standard using your line to ground fault currents. So at least it gives general guidelines for single phase systems. And DC networks, for DC networks, they're still not explicitly covered. But instead of saying in the 2002 version, they said DC systems are not included. That's it. Now they give references. So they give references like the Doan article. So it was a paper by Mr. Doan, who gave equations for DC systems to evaluate arc flash. So for example, in EasyPower, the Doan method would be the one that's used for DC systems under 1 kV. So now the meat of the matter, the CSA Z462 2021 update. So what's new? One of the major changes is, of course, the new Ppe Category 5. So as stated in the polls, I think most of you are not familiar with this new category. So in the technical jargon, it is now considered you can now buy Category 5 suits. So basically, Category 5 is up to 75 calories per centimeter square. So just as a reminder, yeah, Ppe Category 1 is 4 cal, 2 is 8 cal, 3 is 25 cal, 4 is 40 cal, and now the new 5th category is 75 cal. So this opens up the door to new equipment, new PPE for high arc flash results. They also added some text on high visibility apparel. So if you see here, for example, in Ppe Category 1, high vis apparel, they added this text here because there was some time PPE that was high vis. Well, it's now in the tables themselves, and they added some text on hand protection to give some more details on the on hand protection and gloves. There's new definitions. Okay, so I think there was some confusion in the past versions of the standards with regards to what was normal operation, normal condition, because this is you need to know if the equipment is in normal or abnormal conditions to evaluate if there's a risk of an arc flash or not based on table 2 of the standard. So now they added some definition on that. So normal operation means to cause electrical equipment to function within the manufacturer's and engineered system specific design and operational parameters. They also added some dictionary words to make sure that everyone was on the same page. So what is a procedure? What is a process? What is a program? So as I said, they added normal operation in the definitions, and they also changed the name of the section on normal operation. So it was normal operating condition. Now it becomes normal equipment condition. So I think just to clarify and make sure everyone was on the same page, it decided to make this lexical change. So just to remind you, what is normal operating condition or normal equipment condition? So it says that the equipment is properly installed, properly maintained, is used in accordance with instruction included in the applicable CEC standard and the manufacturer's instructions. All equipment doors are closed and secured. All equipment covers are in place and secured, and there is no evidence of impeding failure. So sometimes people ask me, what do they mean by impeding failure? Well, this can be found at the bottom here in the second note. So the phrase evidence of impeding failure means that there is evidence such as arcing, overheating, loose or bound equipment parts, visible damage, or deterioration. So this has been changed a little bit in this version. There is now a new requirement for employers to create and document an electrical safety policy. So this is brand new in the standard. So it says, employers shall create and document an electrical safety policy that affirms the organization's commitment to proactively identify and eliminate electrical hazards and assess and control the associated risks, and create safe work conditions in accordance with the requirements of the standard. So it says that this policy may be documented in the OH&S management system of the companies, if it exists, or in the employer's electrical safety program. So electrical safety policy, if you get audited, or if there's a let's say, an accident or injury or death, if you don't have electrical safety policy for your company, you may be going against the requirements of the CSA Z462. So make sure you're up to date with that. Regarding training, electrical training. So as I've talked about it a little bit. So just to show you here at the bottom, you have the old text for the 2018 version. So it said that for an electrical safety training to be valid, for example, a full day or a 2-day training to say that a certain worker is a qualified worker. So the training shall be classroom or on-the-job training or both. So it did not allow online training or remote training. But now the new text, as you see here, it says shall be designed to achieve specific measurable learning objectives. So the type and extent of the training shall be determined. And then it says classroom training may include interactive electronic or interactive web-based training components, and classroom on the job electronic web-based. So now it allows you to do online training. And also another part, which is specific, very interesting, it says shall be designed to achieve specific measurable learning objectives. So basically, from now on, you need to have a test at the end of your training. You need to measure that the learning objectives have been met for the persons being trained. So you need a test. Before it was not mandatory, but now you need a test basically for the safety training to be compliant with CSA Z462. Now another big change is major change is that the minimum voltage threshold for hazard. Prior to this version, it was 30 volts. Okay, 30 volts AC DC doesn't matter. Now it's been changed to 30 volts AC or 60 volts DC, which means that the 48 volt DC telecom networks are now not considered hazardous voltages. Okay, so it makes it less stringent to work on 48 volt DC systems. I'll show you exactly what changes does this make for working under 60 volts DC. So basically, it's this clause right here, 4.1.6.1 says that voltages greater than 60 volt AC or 60 volt DC shall be put into electrically safe work condition. Okay, and then it says equipment operating at less than or equal to 30 volt AC or 60 volt DC. It says that these parts shall not be required to be de-energized when the capacity of the source and any overcurrent protection between the energy source and the worker are considered. So basically, you could work energized on these systems without following safe work procedures as stated by this standard. So another point on that is that when you are over 30 volt AC or 60 volt DC, all test instruments that are used to test for the absence of voltage shall be verified on any known voltage source before and after an absence of voltage test is performed. So this is a big change for 48 volt DC systems and also for barriers. So barriers are now not required anymore at under 60 volt DC. So big change in the telecom industry, I believe. So another big change is there's a new method that has been added to select PPE levels for AC. So just as a reminder, in the old version, you had 2 ways of finding the PPE level for live work on a specific equipment. You have the tables, the tables method. So basically tables 6A and 6B, 6A for AC, 6B for DC. Or if these tables don't contain the situation that applies to your equipment, you have to use the detailed incident energy method that you needed to model your installation in EasyPower, for example. You needed to generate our flash tables, model every cable, every transformer, every protective device. So you had choice A was you used the pre-calculated tables, or choice B, you do detailed modeling and calculation. Now they added a new table, which is now table V1. So this opens the door when you have some situations. Let's say you're in an installation when you don't have a power system study software, you don't have access to a computer or the internet, and you only have the CSA, the 462 standard with you. Well, there's a new table now that might help you find the right PPE level for live work. So basically, this is a new addition. So they added a bunch of new clauses, a new annex, Annex V. So table 6A, now for AC table method, you can use table 6A or V1, and for DC, table 6B. So it says, just as a reminder, you need to install arc flash tables on equipment which are susceptible to have live work performed on them. You need to specify the voltage, you need to specify the arc flash boundary, you need to specify at least one of the following. So the available incident energy or the PPE category in table 6A or V1 or 6B, but not both. So you cannot put the available incident energy obtained from EasyPower modeling with the PPE category. It says here, but not both. So they don't want anyone to mistake. Let's say you put 4 calories or PPE category 4. Well, there can be a big misunderstanding with that. So they want to make sure that there's no mix and match between energy and categories. So they prohibit adding both informations. So you can also use the minimum arc rating of PPE. So basically, this means you can round up to the upper PPE category. So let's say you calculate 7.1 calories. Well, you round up to 8, which is PPE level 2. And then you can also use site-specific level of PPE. So anything that's site-specific, sometimes results are obtained by zones or by sites, or there's something specific to the installation. And you need to add the date the information was determined. So because you need to update your arc flash study at minimum every 5 years, or when there's a large change in the network, which one comes first. So for the new method, the new V1 method, it's called upon in a bunch of subparts of the standard. So you see here, it refers to V1, 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 V1. So basically, new method V1, new table V1, and method using Annex V are referred to at a lot of new places in the standard. So in Annex V, okay, they added this figure, which is figure V1, which is a bit complicated when you look at it at first, okay? So basically, it's a flow chart that you need to follow before using the new table V1, okay? So basically, you start, and you start at this first condition, and then you see equipment type and nominal voltage are in table V1, and the working distance is equal or greater. So if So this is table V1. So if your equipment is considered here, so does your equipment that you want to find the PPE level, is it considered, is it covered in the list of equipment types and nominal voltages here? So you have to check yes or no. And if you go no, you go to A, and then A goes right over here to A, and then it says incident energy analysis required, which means you need to model your system in software such as EasyPower and find the actual arc flash value. So basically, you go through this, yes, no questions, fuse or circuit breaker, and then you end up, if you end up at the bottom here, it says you can use table V1 to find your Ppe category and your arc flash boundary. So basically, columns 1, 2, and 3 are inputs. So basically, they're related to what equipment you want to find the category. And then columns 4 and 5 are results you get from the table. So Ppe category and arc flash boundary. So this new method seems complicated at first, but it's usable, as I said, in cases when you don't have access to an arc flash study, don't have access to a computer, you need to perform a live work right now. This can help you in cases where table 6A doesn't have the case at hand. Maybe V1 will have the case at hand. So this is interesting in that sense. So there's a lot of new text again related to V1, and then here H2 says that. So section H2 says that use of new table H1 is a simplified approach to provide minimum PPE for electrical workers with facilities with large and diverse electrical systems. So there's a new table which is called H1, which is this one here. It says if you have a large electrical system with large numbers of equipment and you want to find some PPE to use at large in your installation. Well, this can be a good base. This can help you establish the base. So basically, they say everyday work clothing, just choose Ppe category 2, so arc rating of 8 calories, and then this applies to situations where the pre-calculated table, so 6A, V1, 6B, specify Ppe category 1 or 2. And then if the tables say you need Ppe 3 or 4, then you use the arc flash chute, which is 40. So this is basically, if you want the easy way, you can use this. It's a two types of clothing method, which has been added in this version of the standard. So next, there is added guidance on practices where incident energy exceeds available Ppe limits. So now available Ppe limits is over 75 calories. So they basically added the note here. They say where the estimated incident energy exposure is greater than the arc rating of commercially available arc rated PPE. So basically, you're not allowed to perform live work, but you need to make sure that the equipment is de-energized before working on it. So you need to test for the absence of voltage. So the following examples of risk reductions method may be used to reduce the likelihood of occurrence of an arcing event. So they recommend this, use a non-contact proximity test equipment or measure voltage on the secondary side of a PT that's mounted on the equipment to test the absence of voltage below 1000 volts. You can observe visible gaps between equipment conductors and circuit parts and the sources of supply. You can increase the working distance. And you can also use considered system design options to reduce the incident energy level. So I'll go through some ways later for system design options. Basically, they added more details on what methods can you use to reduce incident energy level. Another thing they added is beforehand, they talked about glove classes, but they didn't say in the standard what glove classes were good for what voltage. You had to use another reference for that. But now they added a new table, which is table 4a, says that the glove classes 00024 are good for maximum use AC in volts and maximum use DC in volts. And the distances between the gauntlet and the cuff minimum. So this is a new table you can refer to. Pretty useful. Now I talked before about table 6a. So basically, again, these are pre-calculated R/Ppe categories and R/ boundaries when you don't have access to detailed study, detailed incident energy method. So be careful if you use this table. There are new equipment categories, okay, here. So the results have been recalculated and some new results have been obtained. So make sure you update your studies if they're based on table 6a. And there's also new equipment categories. So they change a bit the text with regards to panel boards, MCCs, and all that. So make sure you're up to date if you use this table at all in past studies. Next, there's a big change with regards to clause 5. So clause 5 was the maintenance requirements. So it's been completely overhauled. If you look here on the right, it was the old table of contents. And now here on the left is the new table of contents. So they basically doubled the number of sections. They added more requirements with regards to maintenance. So I'll go through the main ones. Now they talk about, because in the past, it didn't say that maintenance was needed to be performed by qualified persons, but now they specifically added a paragraph to state that qualified persons are needed for maintenance. It says that single line diagrams, where provided, shall be maintained and shall be kept current. So this was not a requirement before. Now it's a new requirement. If you have a single line diagram, it needs to be maintained. Identification of components. So required signs that identify components shall be visible, securely attached, and maintained. So new maintenance requirements with regards to signs. Same thing with identification of circuits. Same thing with warning signs. So they now need to be maintained. Spaces about electrical equipment. So this new text has been added to make sure that the equipment around the space around electrical equipment on which you're supposed to perform live work needs to be maintained and free of obstacles. They added some requirements of maintenance of grounding and bonding. So grounding conductors, rods, grids shall be electrically tested for continuity, conductivity, and inspected for degradation or missing parts. So this is more stringent. They added this text to be very specific. So you need to do continuity tests for each equipment, for each metal equipment that needs to be grounded, for example, inside every electrical room. Safety equipment. They say that locks, interlocks, and all safety equipment shall be maintained. Same thing for life safety systems. They shall be maintained. So anything that's regarded with regards to fire alarm systems, gas detection systems, emergency lighting systems, and smoke and fumes exhaust systems. Same thing for cables. They need to be maintained, free of damages, short, and grounds. And overhead line clearance shall be maintained. So a lot of new text in this section. I encourage you to review it to make sure that your maintenance plans, maintenance requirements are up to date with the new version. They added also maintenance requirements specific to our flash relays. So the light sensor shall be maintained clean and free from debris. Testing of the light sensing and controls and the current thresholds. Ground fault devices and systems shall be inspected and tested and maintained. Disconnecting switches need to be maintained, and key interlocks too. So a lot more text in that section. And also capacitors. Before performing maintenance on capacitors, they shall be isolated, discharged, and then grounded in accordance with consensus standards or manufacturer's requirements. So new text in the standard. And also equipment in hazardous locations, as per the CEC, shall be maintained with some more stringent requirements, which is from the CEC basically put in the standard. So now another change, small change, it's in Annex A. There was table A1, which says which is the correspondence between the CSA Z462 sections and the CSA Z45001, which is a higher level standard, which is the base for OHS&S, so safety management systems. So basically, the CSA Z462, the way the sections are split up, it's based on CSA 45001. So they remade this table in this version to show you what's the correspondence between the larger standard and the more specific electrical standard. And also they say the intent or objective of each section. So if you go through the CSA Z462 for the first time and you want to see what's the intent or objective of each section, then you can refer to table A1. Another change is they added a new job planning checklist. So let's say you're working in an installation where there's supposed to be live work being performed and there's no job planning checklist in place. Well, you can use this as a base to develop your own. So this is a good basis for planning checklists. So you need to say details, emergency planning, the scope of work, the tasks. You need to identify the hazards, the risk control methods, the shock assessment information, the arc flash assessment information. You need to review the presence of some safety measures. You need to measure attendance, and then before energizing, you need to complete this checklist. So this can be used as a base. So it's figure I.2. There's been also a complete overhaul of Annex O. So it's been updated to provide more and clearer ways to reduce arc flash or shock hazard. So it says very clearly that this is only an informative annex. It's not a mandatory part of the standard. So just to go over the methods they propose, if you want to reduce incident energy, you can use, for example, zone selective interlocking, differential relays, maintenance switches, arc flash relays, line side isolation, arc quenching devices, high resistance grounding, current limiting device, shunt tripping for blown fuses. And then if you want to use safety by design methods, the annex details, well, it gives details for all of these basically, but I'm just listing them out just so you know what can be found in Annex O. So they say, they talk about finger safe components, barriers, disconnects, where you, when you do your design, where do you place the disconnects, cable limiters, inspection windows for IR scanning of joints, ultrasonic ports for non-contact diagnostics, multiple disconnects is always a good way to eliminate the different sources of supply, for example. Instantaneous overcurrent protection, and you can reduce the protection settings for your protections to reduce arc flash, for example, arc-resistant equipment, remote device tracking and deracking, remote device operating, GFCIs, permanent voltage measurement, detection or absence of voltage detection, remote electrical equipment communication, GIS, so gas-insulated switchgear, which can reduce maintenance requirements on switchgears and reduce the occurrence of shock and arc flash hazards. So next, there's a new annex, which is called Annex P. Its title is Electrical Switching and Isolation. So it's just for information purposes only. It's not a mandatory part of the standard. So basically, it gives you some guidances if you want to work, for example, on an equipment inside a switch yard, a substation. How do you come up with a switching order with steps, with which breakers to close, which breakers to open? How do you handle the interlocks? When do you verify the voltages? So this can be used if you want to prepare switching orders. This can be very useful. And there's a new table, a new annex, actually, Annex T, which is called Temporary Protective Grounding. So again, it's informative only. It's not a mandatory part of the standard. So it's basically a new annex that tells you some details about temporary grounds. So how to handle them, how to maintain them, how to install them, what are they used for, and they give table T1 here that gives the maximum fault current rating for different conductor sizes for these temporary grounds. So it's new information that has been added in this standard. So this goes through the changes in the 2021 CSA 462. So as you see, there are a lot of changes in this new version. So I recommend you guys get the new version if you haven't already. Review the changes and make sure your safety procedures and are up to date, and that your RFASH studies are up to date with the new requirements in this new version. So if you want to contact me at any point, here are my coordinates. You can send me an email or give me a call, and it will be a pleasure for me to help you out for anything. So thanks for listening, and now we can take some questions.
Yeah, Simon, there's a couple questions. First one from Rimbin Sala is that he wants to know if he can get a copy of the presentation.
Yeah, the presentation, I will send it over to you, Jim. And maybe you can add a link on the EasyPower website for the PDF slides.
Okay, we'll do that. And the second question is from Victor. He wants to know if the Z462 2021, how does it compare to the Nfpa 70E regarding the Ppe categories?
Well, for Nfpa 70E, basically, there's no Category 5. That is the big change with regards to the US standard. So the lack of Category 5, and also the CSA Z462 does not talk about Category 0, which was a category that was present in the past. So the Category 0 used to be 1.2 calories. Now that any mention of Category 0 has been removed. So, but I believe, if I'm not mistaken, it is still present in the Nfpa 70E. So these would be the two differences in my opinion.
That completes the list of questions we have. Simon, very good job. Thank you very much. We look forward to you joining us in the future.
Thank you, Jim. Have a good day.
You too.